Hey, 8th graders, welcome to our first flipped lesson. We are starting chapter 1, and you can kind of see here the table of contents. Throw your name if you read on here so that if these get lost, we know where to go. A little bit different this year, you guys are going to be responsible for your own vocabulary. Just remember those can be helpful. And so this chapter does have a lot of vocab, but they're all in your book. They should all be highlighted per section. So I would just go through them as you do each section. So today we're going to talk about variables and expressions. So your objective is to be able to translate between words and algebra to evaluate algebraic expressions. So we're going to start, and we're just going to come up with some different words that have to do with these symbols, these signs, operations. So for example, add, addition, plus, more than, sum. Those are just a few. You guys might think of a couple others. This one, I think of minus, subtract, difference, less than. You could do subtraction if you wanted. I think that that's a pretty good start. And then this symbol, I think of the word multiply, times, product, I think those are the most of them. And then the last word here, we have divide. We have, they do say split into equal groups. And then the other one is quotient. Okay. So when we translate something, it means that we take it from one form to another. So if we were translating a language, like we would take it from English to Spanish. Now we're going to translate from algebra to words, to English. And so when I say English wins, it means that we are going to write this in English. So there are more than one way to do that. So I'm going to give you two examples just so you see. So I would say a variable, and I could just use a simple one, plus 3. I could also do a variable increased by 3. And then I'll do one more way just so you guys have a good example. You could do 3 more than a variable. This more than one will throw kiddos off sometimes. Okay, so that's how you translate. So the next one, I have m, like when I look at this, I'd be like m minus 7. That's how I would write this one. A variable, that's what I call m. And sometimes you'll see it like this, a variable m minus 7. Notice how there are no numbers in there anymore? You could also say 7 less than a variable. And when we say a variable, you could have m in there, you could have x in there, it doesn't really matter. Okay, the next one, I could do 2 times a variable. And sometimes you'll see a variable y. You could say the product of 2 and a variable. Like I said, there's more than 2 ways to write it. I'm just doing 2 just to get us started. And the last one here, it's k divided by 5 is how I would say the order of division is kind of like subtraction. It matters. So a variable k divided by 5. You could also say the quotient of k and 5. Okay. So now, like I said, there's multiple ways to take it from algebra to English, but there's really only one way to translate from a word statement to an algebraic statement. So sometimes the order matters. Actually, all the time the order matters, but you have to be careful sometimes. Sometimes you can translate it completely the same. So like this would be 25 times x, like that. Okay? This one, 300 divided by 20 times x. So this one could be 300 divided by 20 times x. So a lot of times the order would be something like this. Sometimes you might see this expressed, usually they're more clear, 300 divided by 20 times x. Most of the time, it would be 300 divided by the product of 20 times x. This one is 18 more than x, so that one we have to be careful. It is actually, you have x to start, and it's 18 more than that, so then your more than is addition. But when they use more than or less than, they're always reversed. Then this one's 11 less than 5 times x, so we have 5 times x, and then we have 11 less than that. Okay. So the next one, we have some word problems. Eve reads 25 pages per hour. Write an expression for the number of pages she reads in h hours. Okay, so this can be kind of confusing sometimes. So if we have h hours, she reads 25 pages per hour. So let's think about how we would write this. They want to know how many pages she reads in h hours. So you would take the total pages would equal 25 times h. Because if I read for 4 hours, 25 pages an hour, she would read 100 pages. They just want an expression. They don't want a final answer, they just want an expression. Okay, again, Sam is 2 years younger than Sue, who is y years old. So sometimes it helps to take this. Sue is y years old. So Sam is younger. So that means I would take Sue's age and I would subtract 2 to get Sam's. So you could also write this out in words. You could do like Sue minus 2 equals Sam. Sometimes that's helpful. And then you put y in for Sue. William runs in a mile in 12 minutes. Write an expression for the number of miles that William runs in m minutes. So this is his per mile minute. We don't know the number of miles. That's our question mark. And so, but we do know that he runs m minutes, and being that he runs 1 mile every 12 minutes, it's division. So if you ran 60 minutes, you would divide it by 12, and that would tell you how many miles Will ran. So sometimes it's confusing, and what I like to do is I like to put in a value for the number, like the number of minutes, and then kind of see how I would work that out. Okay, the last little part here, we are just evaluating algebraic expressions. So you put these in for x and y and z in these problems. So for example, if x is 8, you put an 8 in, and y is 5. So 8 plus 5 gives us 13. If they tell us to evaluate, that means you have to solve and get an answer. The next one, I've got x is 8, z is 4, 8 divided by 4 is 2. Last one here, z is 4, x is 8, and y is 5. Remember order of operations, we have to take 8 times 5 first, and you get 40. So 4 plus 40 gives us 44. The last little problem. Approximately 14 20-ounce plastic drink bottles must be recycled to produce 1 square foot of carpet. So it's basically telling us that 14 bottles, doesn't matter what size they are in this problem. Nope, so I'm gonna get rid of that. Must be recycled to produce 1 square foot. So I like to sometimes write this out. 14 bottles equals 1 square foot of carpet. Okay, so write an expression for the number of bottles needed to make C square feet of carpet. So for example, if you need a certain number of square feet of carpet, so like let's say I need 10, let's pretend. So let's pretend you need 10 square feet of carpet. When you do this, then you can say how many bottles. Well, if you know that 14 bottles gives you 1 square foot, what would you do with this 10? Well, you would take 14 times 10 and you get 140. Well, in this case, we're taking 14 times the number of square feet, so we do 14 times C equals total bottles. Okay, so then we're going to do it for these 3 numbers. So sometimes I like to make a little chart. If we've got 14C, I've got 14 times 40, 14 times 120, and 14 times 224. That will give us our total bottles. 14 times 40 gives us 560. 14 times 120 is 1680. And 14 times 224 gives us 3,136. And then the label of these are obviously bottles. Those would be your answers. Okay, so being able to translate, so pay attention to the wording and then being able to solve an equation. Thanks, guys.